Right, so 16L. Right, so today we're looking at sketching 10 functions, tangent lines. So it's slightly different to our sine and cosine graphs. They don't follow the normal period range kind of rules. So what we get is the period for a tan line, tan line, is just pi over n, not 2 pi over n, like before. There is a dilation of factor A from the x-axis and factor 1 over n from the y-axis. Right, not terribly important for you to know, but sometimes questions are framed that way and you have to figure out what A or what N is. The range is just R. It's always R. So from negative infinity up to infinity, it's just the entire set of real numbers. The asymptotes. Right, tan lines have asymptotes where the line approaches but never crosses or touches. And it is at x equals 2k plus 1 times pi over n, where k, right, this k is not the same k in the formula, by the way. K is an integer. Such as -2, -1, 0, 1, 2, ... Right, just any whole number, basically. And the only other thing you need to know is the x-intercepts. And they are located at x equals k times pi over n, again, where k is an integer. So a basic tan graph, this is your x-axis, this is your y-axis. You've got vertical asymptotes at even intervals. And your tan graph looks like this. Right, just keeps going, curving around, curving around, curving around. So it approaches these asymptotes on both sides, up and down, and it just repeats itself.
And it doesn't reach the asymptote, or?
It never touches or crosses the asymptote. Gets very, very close to it, but never touches it. Okay. Right, so let's try an example. Let's start off with the most basic one and just say y equals tan x. So we need to find the period. We need to find the, oh, we don't really need to find the range because we know that it equals R. We need to find the asymptotes. Let's say from -2 pi to 2 pi. Otherwise, we have to draw an infinitely long graph. Right, so asymptotes and x-intercepts. Yeah, n is usually in front of the x. In this case, it's 1, so we got pi on 1, which is pi. Our asymptotes, x equals, right, you got, let's just try 0 to start with. 2 times 0 plus 1 times pi over 2n, and n is 1.
So you're making k in this case 0.
Yeah, you just choose k values at random.
Oh,
So usually start around 0 and then try maybe 1 and -1 and 2 and -2 until you've got enough.
Oh, you use this value.
No, they're all just whole numbers.
Right.
Yeah.
Isn't there like a 2 in front of the 0?
A 2, well, yeah, but 2 times 0 is 0.
I just wanted to like see if that was
Yeah, it's 2 times k. And our k is 0, so 2 times 0 is 0. Yeah, Ben.
Could you please write the general formula with like the n's and k's?
You didn't write it down? The last slide. All right. You just wrote it down a second ago.
I was a bit like
2k plus 1 pi over
okay, don't worry.
2n.
Yeah, go.
So we get, it was 0 plus 1 times pi, so that's just pi on 2. And now what would you have if k was 1?
3 pi over 2.
3 pi over 2, yep. What would you have if k was -1?
Negative pi over 2.
Yep. And what would you have if k was 2? 5 pi on 2. And if k was -2?
Negative 3 pi over 2.
Negative
3 pi.
3 pi on 2. Okay, great. 5 pi on 2, do we need it?
No, because it's outside the domain. Yeah.
It's outside the domain, so we don't really need it. Right, you just go keep choosing k values until you get outside the domain, and then you know to stop. Yeah.
So we don't need negative 3 on 2 either? Yeah, how'd that come off? It's negative 2 pi.
That's negative 1.5, so that's fine. It's within this.
Okay.
How did we get what?
Did you put the numbers in the same order?
No, I did k equals 0, k equals 1, k equals -1, k equals 2, k equals -2. Yeah. So I'll say k equals 0, 1, -1, 2, -2. Right, that's what they each were. Okay, and now x-intercepts, which is just x equals k pi over n. Our n is 1, so it's just going to be something pi over 1, which is something pi. So we'll go 0, pi over 1, which is just 0. If it was 1, we'd have pi. If it was -1, we'd have -pi. If it was 2, we'd have 2 pi, and if it was -2, we'd have -2 pi. Those two are solutions because we've got inclusive brackets.
Yeah.
Okay, that's all we need to know, and now we can sketch it. Yeah, x-axis. This is our y-axis. So we'll draw in 2 pi, pi, pi on 2, 3 pi on 2. About there, there, and there. Negative 2 pi, negative pi, negative pi on 2, negative 3 pi on 2. And now we're just going to start by drawing in our asymptotes. So we've got one at x equals pi on 2, so we can draw in our asymptote. We've got one at 3 pi on 2, draw in that one. We've got one at negative pi on 2, draw in that one. And we've got one at negative 3 pi on 2. Right, x-intercepts, we've got one at 0 here, got one at pi, 2 pi, negative 2 pi. It's a positive tan graph, right? It's not a negative in front, so we know that it's going to start up at the top right and go down to the bottom left. So all you have to do is basically just kind of draw it in so that the point of inflection is at the x-intercept. Right, keep in mind that this one would have come down here, hit the x-intercept and then gone down, but we don't want to draw anything that goes up because we only want it to 2 pi. Yep, so this one would start up here and then hit that and stop. And there you go, it's the basic tan graph. Quite straightforward. You want to try a harder one?
We just go on the next bit and then sort it out. We can ask just a question.
Okay, y equals 3 tan 2x plus 1 for x values between 0 and 4 pi.
So we're subbing in the same numbers for our k?
Yep. K is just always whole numbers, so 0, 1, -1, 2, -2, but you need to choose appropriate k values. So if it's from 0 to 4 pi, you're not going to go down like -2, -3, because it'll probably give you answers that are outside your domain.
Okay. Because it's below 0, yeah.
So like if you choose -1 and it's already less than your like lower domain, you wouldn't keep going negative because it's going to get more and more outside the domain. You go back the other way. Right, so period pi over n is 2, so get pi over 2. Yes?
The last one, how did we get pi over 2 because n was 1 plus 1.
We didn't have pi over 2. Right, let's check. Asymptote. So if I'll write it down so we can see. X equals 2k plus 1 pi over 2n. In this case, our n is 2, so that's going to be 4. Right, so if k equals 0, we get pi on 4. If k equals 1, we get 3 pi on 4. If k equals 2, we get 5 pi on 4.
Miss, where's the 4 come from?
2n. N is 2, so 2 times 2 is 4.
Just on the original.
Did I?
Yeah.
Sorry, change it to 2n.
Yeah.
Right, so 7 pi on 4, 9 pi on 4, 11 pi on 4,
So pi on 4 will be
12 pi on 4.
no one more. Let me say 13.
Sorry, 13. 15 pi on 4. And stop. Because it would be outside of 4 pi on 4 pi. Yeah. All right. X-intercepts are at K equals, sorry, X equals K pi on N. So N is 2. So let's just put 2 down there. So then we just go through again. We got when it equals 0, we got 0. When it equals 1, we got pi on 2. When it equals 2, you got pi, because it's 2 pi on 2. Cancel each other out. 3 pi on 2. So yeah, it's just going up by halves. So you got 2 pi. 5 pi on 2. 3 pi. 7 pi on 2. And 4 pi. That should be enough. X and Y.
Yeah.
Yep, so these are not x-intercept, these are the points of inflection.
Does that matter? Wasn't like
Couldn't we, if they're all the lines are like not stretched out, they're all like the same relative shape, could you make a formula just to, with using how much it's trending up and down and figure out what the x-intercept would be?
You could definitely use the unit circle to find 1 and then add on the period to it every time, because they'd be exactly pi on 2 distance away from each other. So it's not too bad. But let's just go with what we've got so far, and then we'll work out the x-axis intercepts.
I don't know if for their course this year whether they actually have to do that.
Right, so because it's been moved up one space, they're no longer x-axis intercepts. They are now the x values of each point of inflection with 1. So let's put a 1 here. This will be our 4 pi. Halfway is 2 pi, 3 pi, pi, and let's just split each of those into a half.
yeah.
I hope. Oh, quarters, because we've got quarters asymptote. As long as you know where to put them, it's fine. You don't have to label every single one. Right, so let's fill in our asymptotes. So we've got one at 1/4, so that will be down here. We've got one at 3/4, so down here. And you can see that it'll just go through every single one halfway.
Oh my gosh.
So there's quite a few of them.
Yeah.
Okay, our what once were x-intercepts are now being moved up by 1 space. So 0 is now up here. Pi on 2 would have been here, but it's now up here. Pi would have been on the x-axis, but it's now moved up 1 space. So you can kind of see it's going to look exactly the same as it was going to, but now it's just been moved up by 1 space. Yep. It's really not that bad, I promise. It's actually easier than a sine and cosine graph. And yeah, basically just fill it all in. And then this one will only go down. Right, let's figure out what these axis intercepts are. So how do you find an intercept? Make y equals 0. So we're going to go up here. It'll be 0 equals 3, 10, 2x plus 1. Rearrange that. So you'd get 10, 2x equals negative 1 on 3. Right, so you just do 2x equals inverse 10 of 1 on 3. So you just do inverse 10 of negative 1 on 3. No. Right, so we get inverse 10 of 1 over 3 is 0.32, but so that's like somewhere out here. But because we want negative 1 on 3, our tan has to be negative. What are the two quadrants where tan is negative?
The
second and fourth. Right, so we want this one out here and this one out here. So we want pi minus theta and 2 pi minus theta. So you got to do pi minus this and 2 pi minus this to work out the angles. Right, so when we did pi minus 0.321750 or whatever, we get this one to be 2.82. And then we got to divide that by 2 because remember it's 2x. So squishing it in. Divided by 2 is 1.4. Right, so this is 1.4.
Can we just add?
Yeah, so now we just add the period each time. So pi on 2 to each one because they're exactly pi on 2 apart. So we do 1.40992105 plus.
Sorry, I didn't get that one.
That's just the decimal. It's not 1.4. It's 1.4 blah, blah, blah. Yeah. So now I'm just going to add pi on 2 to it, and we get 2.98. So it's technically 41. And then we just do that answer plus pi on 2. 4.55. Add pi on 2. 6.12. Add pi on 2. It gets very easy from here on. 7.69. 9.26. 10.83. And 12.41. So those are your axis intercepts, x-axis intercepts.
Wow, that's such an easy question.
It's no different to what we've been doing.